information. The rest is just reading the graph. So it says the path of the rocket is given by the equation. And anytime they give you an equation, just so that you know, even if they don't give you a graph, what can you do? You can just go ahead and punch that in and you get that exact same graph. All right, so remember, always clear your calculator. So second plus 712, second plus 722, stat 5, enter. So my calculator is ready to be used. Punch in what it says. So y equals negative 16 x squared plus 128 x. Hit the graph, and I should get something that looks like this. And it looks like this goes from 0 to 8, and then 0 to like 250. So it's not going to fit in my screen. So what do? I hit zoom fit, which is zoom 0.
This is a listening check. Underline the title, Projectile Motion.
And I don't need all of this space right here, so I'm gonna bring my Y up and then increase my space on this side. So I go to window, and then on my Y, see my minimum, my Y is so big, I'll just leave it at like negative 10, and it goes up to like 250. So I'll just make it 300, and instead of making it go up in 1 so it can appear, let's make it go up in, shall we do 10s and see what happens? And you can always mess around with the calculator to see what happens. Boom. Okay, nice and big, and it looks just like that. That's what I'm looking for. All right, so the question is, how long is the rocket in the air? How long? All right, how long has to do with what? Does it have to do with time, or does it have to do with height? Okay, how long? Time or height? Time. Okay, how long is this rocket in the air? So the rocket shoots off. Okay, it gets all this speed, then at some point it runs out of fuel, and then it falls back down, right? So how long is it in the air? It's in the air until it hits the ground, which is this entire time right here, which is what? 8 seconds. So
this is a listening check. Color in the equation. H equals negative 16t squared plus 120.
What is the greatest height the rocket reaches? So once again, it goes up, then it comes down, right? So this is time, and this is height. So what is the greatest height it reaches? What's the highest point that you can see? Hopefully you're seeing it right here. And because this isn't an exact, most of the time when they give you a graph, you can give it roughly. So it's just a little bit over 250. But I want to show you real quick in the calculator. And remember, everything I need is in calculate. So you hit second, calculate, maximum, left, take your spider to your left, take your spider to your right, enter, and guess. And you can see it's the same thing, 256. So what's the greatest height the rocket reaches? 256. And you just need to put the units, which is in feet. All right, how high is the rocket after 1 second? So you go to 1 second. So how high is it? How high is it after 1 second? 1 second, and it's a little bit over 100. This looks like, if that's like 112-ish, 113. And so I go second, calculate, and I want to calculate the value of x at what? At 1. So hit 1. There you go, 112. I was pretty close.
This is a listening check. Color in the words how high in question 3.
After 2 seconds, about how high is the rocket? So I can definitely estimate this one. After 2 seconds, how high is it? It's really close to 200. So let's say about 190-ish. Okay, so if it's an estimation, they'll take that. If not, if you need to know the exact, go second, calculate. What value am I putting in? And I want it after 2 seconds for x. So 192 feet. Is the rocket going up or down after 2 seconds? So right here at 2 seconds, is it going up or down? Obviously it's going up because you can see it's on this side of the curve. So it is going up. After 6 seconds, about how high is the rocket? So at 6 seconds, how high is it? So it's that same value that I found at 2 seconds. So what was the one at 2 seconds? It was 192 feet. And once again, I can check that. So I can go second, calculate, enter, and I'm looking for 6 seconds. And you can see it's 192 because it's now at the same height it was before. Is the rocket going up or down? At this point, at 6 seconds right here, it's going down.
This is a listening check. Color in 6 seconds. After 6 seconds.
A swim team member performs a dive from a 14-high springboard. So the springboard is obviously above the pool, right? And then the guy jumps up, he springs off of it, and then he comes all the way down. This is gonna be time in seconds. All right, so how long did it take for him to hit the water? Okay, so when he jumped, and then this is how high it was, and then he hit the water over here, right? How many seconds is that? 8. So that's 8. And don't forget to write the units. How high did he jump? So he started here, he jumped up, and then he started going down, right? So how high did he jump? So what's the tallest point? Right about here. So that's, if this is going up in 16, 18, 20, 22, maybe 23. So 23 feet. Last question, at what time was he 8 feet above the water? So this is how high it is. You're looking for 8 feet, which is right here.
This is a listening check. Circle question 3.
So right about here. Okay, so if this goes 6, 7, then 8, right? He's about halfway. So 6.5 seconds. Last question, they do not give you a graph. They're just asking you a question, okay? So while working on the roof, Rob dropped his hammer, okay? The hammer falls and can be represented by the equation blah, where T is the time in seconds and H is the height of feet. How long will it take the hammer to hit the ground? All right, so the very first thing you need to do is put that in the graphing calculator. So you go y equals and clear what you have, and then you go negative 16x squared plus 20. You hit graph. Now my graph is weird because it's from the last question. So again, how do I make this fit into this calculator? I go zoom, zoom, fit, which is all the way down at 0. Press enter. So it's gonna make it fit for me. Okay, but I need to see this like top part right here. So I'm gonna less y here and more y on the top. So you go to window. All right, so my minimum does not need to be this big. So I'm just gonna make my minimum like negative 10. My maximum, let me leave it at 20 actually, going up in 1, and let me see what that does. How long will it take for that hammer to the ground? I want to know where it crosses what? The x-axis, this distance here. I'm just looking for the x-intercept, which means I can do like second calculate my 0, press enter, and left of here. So there's my spider, make sure it's on the left, and then right of here. Boom. Press enter. Guess my 0 happens at 1.1.
This is a listening check. Put a box around example 3.
So let's practice.